Welcome, everyone. Thank you so much for joining us today. My name is Sophia, and I'm going to be your host. Let me introduce you to my colleagues. I'm joined by Irfan Sayed, Director of Quality Engineering at Progress, and Bijou George, Senior Principal Solutions Engineer for the Progress Data Platform. And today, Irfan and Bijou are going to demystify Model Context Protocol for you. Now, in a minute, I'm going to let them introduce themselves. And after that, we're going to be talking about, first of all, why MCP needs demystifying, what it is not. And when we talk about MCP, we have to talk about AI agents. Now, agentic AI is the buzzword of today, and it's going to be the word of 2026. Now, there's a lot of hype around agents because of their promise to completely transform the way we work and also the way we interact with information. But there are also a lot of questions around where MCP can bring a lot of value, which is why we're also going to be talking about how to actually design an MCP workflow and what are the best practices for developing and managing MCP servers. Now, there is no doubt that agents are the next frontier in generative AI, as they're helping us move from asking a question in natural language and getting a good enough answer into a more sophisticated use of generative AI that actually help us orchestrate and build autonomous execution of tasks. Now, that's why I'm really excited about the last point on our agenda for today. We are going to talk about a product on the Progress roadmap that is going to help you build those agentic flows to automate tasks in 2026. Now, I'm excited, and I hope you guys are also excited. So let's get into it. With that, guys, take it away.
Thank you so much, Sophia. It's a great introduction. I really liked it. I'm really excited about it to talk about it. I'm sure Biju is also. So before we go into the topic, let me introduce myself. I'm Irfan Sayed. I'm the Director of Quality Engineering for the ADP organization at Progress Software. I've been in Progress for around 15 years, working at various products of Progress like OpenEdge, uh, Agentic RAG, WhatsApp Gold, Loadmaster, and I think the discussions that we're going to have today will be really, really nice and interesting, talking about the work across various products in Progress. Biju?
Thank you, Rafan. Hi, everyone. My name is Bijou George. I'm a senior solutions engineer with MarkLogic. I've been with MarkLogic and later Progress MarkLogic. Together, I have more than 8 years of experience with the MarkLogic product. And currently, I handle the MarkLogic portfolio from a sales perspective and also a couple of other data-related products of Progress, like Semaphore and Corticon, etc. So yeah, excited. Most of my recent work have been around generative AI, so it will be an exciting interaction. Thank you.
Awesome. So as you might have seen from both of our careers at Progress, we haven't interacted or worked on one single product together. So what seems to happen is that we both were working on a new technology called as MCP, which is Model Context Protocol. And then we both were intrigued by it and we started exploring what can we do to implement that in our products. And while doing so, we were able to figure out certain things and we wanted to share about it. And this webinar, this presentation, the initial part of it is about how have we learned about MCP being a great builder, great integrator in your products, number one. Number two is that we would also like to explore what can be done in MarkLogic to use the MCP protocol. And the most important part that Sophia mentioned, and I'm also really excited, is about how the world right now is beyond a certain protocol. It's about tasks. How can we manage and execute multiple tasks? So what is Progress offering to do that? So with that, let's go into the world and deep dive into what MCP is. What is Model Context Protocol? Model Context Protocol is an open standard that lets AI models securely connect to external data sources or tools or applications in a consistent, interoperable way. As I was mentioning to you, this was something that initially started last year in November 2024, where Anthropic, it figured out that when we had AI and then we were trying to integrate AI solutions, and we had IDEs that can go and help us build uh, LLM-based interactions, the context window was getting so smaller, and they figured out that maybe the way we are doing is wrong, and we need to do something much better. That's where Model Context Protocol came into picture. Model Context Protocol was something that really helps uh, any kind of clients like IDEs, mobile applications, desktop applications to get the context on demand and then talk with an LLM. That makes the problem of having a larger context problem being solved. So though it was initially meant to be and built for IDEs like Claude Code or VS Code, the expansion or the idea of how it could be utilized for enterprise solutions really, really grew. And then we're going to talk about how people are really using it at this point of time. So if you think about Model Context Protocol from a protocol point of view and how it is being utilized as a client server application, it looks something like this. Let's start with the right side, which is MCP servers. You can create MCP servers for your own any kind of servers. It could be Salesforce, Postgres, Vault, a database, uh, doesn't matter. The MCP is a protocol that will help you create MCP servers by using their protocol SDKs. And now, then we have MCP client. MCP client, just like any client server, it interacts with the server, executes a specific functionality, and retrieves the data. And then we have user applications. User applications are browser-based applications, IDEs, chats, whatnot, anything. Now, how does this work in the AI world? How does this help, or how is it different from your regular client server application? The difference here is that MCP client, it basically takes the user input and then it also interacts with the MCP server, gets the functionality of the MCP server, and asks the LLM for the given question that the user asked, what is the right API to execute? What is the right tool to execute? And then LLM being a judge, it recommends the right tool to you, which is an MCP client in this case, and then MCP client executes the tool and returns back the data to the user. That's basically it in simple terms. It provides you a model context protocol between the client and the server using JSON over RPC protocol. That's it. Now, why MCP needs demystifying? I mean, though it's been a technology that's been utilized for the past 1 year by many, many industries, it's always confusing when I talk to people. When I talk about MCP and what it does, it's really, really confusing for some people. And the reasons are confusing name. Model context protocol, it just looks like some kind of HTTP protocol, but it's beyond the protocol. Technically, it means that you're exposing AI to your systems in this world using this MCP technology. But the way you go ahead and see it, it's just a protocol, but it's not. Complex documentation. The documentation is very, very complicated. You only see the documentation is focused on JSON RPC specs instead of saying in very, very simple terms that how can you let AI access your data. The documentation and the specs are mostly focused on developer first, which is they talk about the implementation details, but they do not talk about if you implement MCP, what is the value you get? Multiple moving parts. If you look at the client server protocol stack, you have to implement the client, you have to implement the server, and what protocol they have to manage in order to communicate with it. There are multiple pieces inside it, and understanding what they are, it's a little complicated. Abstract examples and demos. If you look at the demos of MCP server, each one will be very, very different kind of hello world examples. Instead of saying that AI reads your CRM data, AI reads your own application data. Instead of that, you have very uh, generic examples which do not add a lot of business value. Jargon overloaded. There are many, many terms inside the MCP. One of them is like, I'm giving example here as capabilities exchange, which talks about what kind of things that the client and the server has to do while they're doing a handshake. Instead of saying simple AI functions, they basically go with the word capabilities exchange, which no one understands. So for that case, I think we need some demystification of MCP, try to get down into the details, and then understand what it does, why it does, and how is it better in the world of extracting and retrieving the data.
So Irfan, one question I had when I was seeing this, I have some experience with the MCP, but at the same time, I still consider myself in the learning phase actually. So here the objective is to connect the LLMs to your corporate data, right, or your enterprise data. Why MCP becomes the only standard there? Any thoughts around that?
That's a good question, Biju. So let's go with an example and let's deep dive with an example. So first of all, MCP, the whole purpose that MCP is trying to do here is that MCP is a standardized protocol that lets AI securely access your files, your database, and apps for better answers. You don't need to do any kind of custom integrations on top of what you do while building the application. So for the question that you asked, let's go with an example where you have a use case where you have to build a AI customer assistant that securely pulls orders, create tickets, checks inventories, and portable across various LLM models. The LLM models could be, as you were mentioning, Claude, OpenAPI, or Gemini, whatever it could be. So if I have to build a system like that, I have multiple choices. And if I was in the world or in the time before MCP, then the choice for me is that I would be building an AI agent. The AI agent could be where we have many kits or language libraries that can help us to build AI agents using the LLM specific agents or generic agents which can use any of the LLMs and then can go and communicate with the servers. So let's take this as an example where I have to build an AI agent here in the left side. I want to build a customer support application. I will have an ERP API, a help desk API, a warehouse API, and I'm trying to build an LLM API. That API will be something that can be used as an interface to communicate with my AI agent or AI solution. I could similarly do that for my database solutions. So where I could do SQL kind of DB exposed as an AI agent over an AI agent solution, ERP system, or a file system. This is all perfectly good. The problems that you're going to get when you try to build this kind of solution and over the time is that this is not standard. So you try to build a solution only you can use. The moment you want to expand the solution, the moment you want to say that I would like to take this solution and then integrate with something else, then the protocols do not match. You talk in some of the technology, and then some other application is using some other technology. The real-time problems that we are maintenance challenges. Multiple system, multiple protocol. We end up having an n times n problem and duplicate AI layers per system. And then security issues. You have nothing as defined in security and all or nothing access or hard-coded credentials in integrations because you're not following a standard, proper standard in building AI agents with security. Performance and efficiency, fresh context fetched for every request. There is no caching concept involved here. Scalability limits. Integration complexity grows exponentially, and adding new AI providers requires rewrites, a lot of rewrites. And development and operations overhead, high technical debt accumulation. The reason is you're trying to build a solution which is basically uh, not a standard, and you're trying to build a standard on top of it. And while you do that, difficulty debugging your heterogeneous systems, which will be very, very hard. And combining all of that, the business impact while you do and you maintain this is much, much higher. It is slow time to market for new AI features, and it's high cost for integration and maintenance. So combining all of these factors, we think building something would be very easy if I was not using MCP. But with MCP, it tries to mitigate all these issues, and it tries to build us a unanimous, unified solution to expose or to retrieve your data and to expose your data as an over the MCP protocol. Now, if you look into the MCP client with the same approach, with the same use case that I was mentioning to you before, so all we need here is an MCP client and the MCP protocol layer in between. That's it, which provides a unified interface, intelligent routing, standard communication, and then it will provide you ability to straight away go and talk with the downstream MCP servers if they're exposed as MCP servers. It could be a ERP solution, it could be a database server, it could be a solution which are tool specific, which are like Docker, Google Maps, or GitHub, or it could be a internet-based driver. It doesn't matter what they are. If you follow a standard protocol, which is an MCP, it will basically help you to just expose them as services or functions and use a common client to go and interact with them. It provides a multimodal interoperability supports, and so basically acts as a connector to talk with any of the AI models. It makes a connection and helps in making stateful in management between the client and the server. It provides you ability to perform fine-grained integration for security by both internal as well as external integrations. Real-time tool discovery, which means that when you try to add multiple APIs inside your MCP servers, then they get automatically get discovered. And unified interface where you have same pattern for all integrations. The advantage that you get is that when you have functions like this, which these below MCP servers exposed, they are just exposed as functions from the MCP servers, but then it goes all the way to the MCP layer where it can understand what these functions do. And when a user asks a question, they can easily go and execute a specific MCP function. So that's the functionality of how MCP architecture is, how it works in a nutshell. But to make it more clear, I think we need to go a little deeper and understand about the functions of MCP, and we need to talk about how each one of them are executed. So, what is MCP server and what are the functions of it? MCP server starts by exposing its functions or features as tools, resources, and prompts. The protocol that MCP server uses is JSON RPC, which I mentioned earlier, and the transport protocol that is required for to start the MCP server and communicate is STDIO, which is called as standard input output, and then HTTP. STDIO protocol is something that people use if you would like to build MCP server on desktop-based applications where there's no network interaction required. HTTP, on the other hand, is where you want to deploy your servers as enterprise solutions, and then you would like to connect to it securely. For that purpose, you basically go ahead and use HTTP as a transport protocol. Now, I mentioned about tools, resources, and prompts. Let's go into each one of them. What are tools? Tools are nothing but external services that the model can call via the MCP protocol to fetch data or perform actions. They basically are enabling it to interact with business system to access real-time information securely and safely. In one term, if I have to explain what tools are, then they are basically APIs. We are just exposing the APIs, like REST APIs, as MCP tools. Examples could be you want to perform a database query tool for fetching inventory levels. You would like to retrieve an API to get the customer related information from the customer portal, etc., etc. Then comes prompts. Tools do a specific job of executing a specific functionality, and but they only are small in scope. They do a specific job of or a task and then execute something and return back the response. Whereas prompts are something which are reusable templates that can guide AI responses and coordinate multiple tools for complex workflows. For example, if you would like to do some kind of a product recommendation, in order to do a product recommendation, you would like to go through N steps. Step one, try to figure out if you have any support tickets for the existing product. Step two, do you have any stock level availability? Step three, what is the inventory availability, etc., etc., etc. And you want to define this as a workflow. And that is where prompts come into picture. You can define MCP prompts that tells you that I have designated tools for this server, and I would like to execute you tool one, tool two, tool three, and then with the certain parameters and get the response back to the user. And then comes resources. Resources are data sources, which could be static or dynamic, that the model can reference to inform its responses and provide context aware answers. It is mostly used where you want to return something or you want to expose something like a knowledge base article. You would like to expose customer inventory as a CSV file. So any of your knowledge box information or any of your knowledge base information or metadata, if it want to be exposed, you can expose them as MCP resources. So combining all of them, tools, prompts, and resources, they all provide different functionalities for you to expose your data back to the user application. Now let's look into a user MCP workflow so that we'll start with how they interact, the client, server, and the user application, and how do we make sure that when a user asks a question, what process it goes through. So the first and foremost thing is that let's say user application, it asks a question, then the MCP client will try to make a handshake with the MCP server, just like any other protocol that you know about, like HTTP or TLS, they try to make a handshake. So as part of the handshake, they first do initialize and capabilities exchange. So what are capabilities exchange? Capabilities exchange are during initialization of the MCP protocol between the client and server, they both declare what kind of features they support. The features include, do you support tools? Do you support resources? Do you support prompts? Do you support sampling? Sampling is something additional which basically tells you that whether the server can execute or request for LLM completions. Like right now, the MCP server doesn't need LLM, but if in case the MCP server needs LLM to execute certain things, then it can go and ask the MCP client for LLM access. So that is called sampling. So all these capabilities of feature exchange are being provided by the MCP client. And it says that as part of Handshake, I have these features and I'm going to connect to you. MCP server validates the capabilities that the MCP client has, and then it provides back the capabilities, tools, prompts, and resources that the MCP server supports back to the MCP client. Now the client and the server, they both understood everything and they both handshake. The initialization of the connection between MCP client and the MCP server is complete at this stage. After initialization, connection remains persistent. Client can make requests to the tools, prompts, resources, and server can send notifications about any changes that happens on the server side. Both sides, client and server, can handle errors and maintain connection state. Now, let's look with a workflow, with an example, right? Now, user submits a query. The question goes something like this: show me all the inventory available. Now, when the user asks this question, he sends the question to the MCP client. MCP client, it forwards the query and the server info to the LLM. What does server info mean here? Server info means by this time when the MCP client interacted with the MCP server as part of initialization, it has knowledge about the tools, the prompts, and the resources that the MCP server supports. So it takes all the information and the requested query and then takes all the way to the LLM and says that I have this question and I have this context of the APIs that I can execute. Recommend me which tool should I execute. Then the LLM, it comes back to the MCP client and says that this is the tool that you should be executing. Then MCP client executes the recommended tools with the right parameters on the MCP server. MCP server executes the tool because it doesn't need anything. It's just an API interface at that point of time. It's a function interface. It just executes the tools and returns the response. Once the response is returned to the MCP client, the client forwards the results to the LLM and says that for this question, this is what result I got. LLM incorporates this new information into a reasoning and decides if it has to call additional tools, additional prompts to get more information, or is it sufficient? If it is sufficient, if it does not need to generate external more tools or execute more tools, it will basically generate a final response using all the available context it got. So finally, the kind of response that it would be getting is that I have this raw materials information, which work in progress is this, finished goods, etc., which you might be returning the data from the MCP server as a JSON format or XML format. MCP client, with the help of LLM, it converts that into a textual format and provides you something like this. It's as simple as that. That is the communication that happens between MCP client, MCP server using the user application. It's just another client server interaction, but we're talking about an API in the AI space. Now that we have looked into what MCP server is, what it does, how does the workflow works, I think it's very important for us to know that what MCP is not and what it is not capable of. What MCP is not is that it's not another AI model. People think that it's an AI model, but it is not an AI model. MCP doesn't do anything with the AI in itself, but it goes and interacts with AI as and when needed. As we were talking in the previous example, the MCP client is the only one that will go and interact with the LLM to be a judge, to be a recommendation tool, to tell which tool to execute and summarization of the tool. It is not a storage system. It's up to you to define your own storage. MCP doesn't store your data. It provides only secure access to existing systems. It's not an AI agent platform. When you think about an AI agent platform, MCP takes a small part in that AI agent platform if you try to build it, but it doesn't encompass any AI agent platform functionality in total. A fix for bad AI. MCP will not enhance the underlying AI technology or responding or reasoning that an LLM can give, because MCP here is a mere tool, but it doesn't do anything with what AI or LLM can provide. MCP client server compatibility isn't universal, which means that your client might not be supporting all protocols that the MCP server might support. You might be building an MCP server which has tools, functions, tools, prompts, and resources, but your client might not be supporting all of them. Your client might be supporting only tools and resources. So it is, in general, if you are using a proper SDKs and proper libraries between client and server, both are compatible. It makes sense that they both can talk to each other with the capabilities they have. But if they do not, then they both cannot talk to each other. So it's up to the development of a solution on how we want to build the solution and make sure that we are building a compatible solution between client and the server. Ready to use out of the box. That is not completely true. If MCP is just a protocol where they provide you a bunch of SDKs, there are many libraries that basically are built based on MCP, and it's up to us to implement this as part of our solution, as part of a product, and then expose them as MCP servers, and then build the MCP or AI level application to go and interact with MCP. Bottom line, MCP is a universal connector between AI and your world. That is all it is. MCP lets you interact with your applications and expose once they are exposed them as MCP servers, it lets the world of AI can go and talk with it using a standard protocol.
Okay, thank you, Irfan. That was very insightful. In fact, the second last slide you had is well, those were the exact kind of confusions that I had when I started in learning about or hearing about MCP and then started learning about it actually. Okay, so in the next session, I'm going to share my experience of how I could build a MCP server on top of MarkLogic database. So here we will focus in this session. We'll focus completely on the MarkLogic database. So of course, as Irfan was mentioning, Model Context Protocol started gaining momentum since Anthropic open source date. And my introduction to MCP came during a proof of concept with a customer. And we were implementing retrieval augmented generation over unstructured data, content, basically PDF content stored in MarkLogic. However, their broader data landscape included structured tables, semi-structured JSON data, and some graph data over triples. And of course, the overall program goal beyond the POC was to enable retrieval across all these data formats to complete a use case story. Okay. But interestingly, during one of the planning discussion, the customer expressed the interest in shifting towards agentic AI, and that was somewhere around early. In fact, it was in March 2025 is where I started hearing about it actually. Of course, starting with a single agent, but their vision was additional agents retrieving both structured and unstructured data, orchestration between multiple agents, and minimizing data movement across the systems. And they were learning about it as well along with us actually. And one of the key concerns that they expressed at that time was, okay, they don't see anything called as a MarkLogic MCP server. So do we need to really move the data into a different database depending on the data format? And that was a serious worry for them and for any MarkLogic customer, I would think so, because one of the MarkLogic's major advantages is its ability to manage different diverse data formats in a single storage engine, right? So the idea of moving data for the purpose of agentic workflow was a serious worry. But what I did was basically, okay, that's when I got introduced to MCP, and I was definitely challenged with all the things that Irfan was mentioning, like the jargon, a lot of jargons going around. The examples are very simple. But what I came across was Spring AI. So within a couple of days, using Spring AI, I was able to demonstrate a fully functional MarkLogic server with a couple of tools to start with. But the impact was it directly resolved the concern that they had actually, and they could validate the workflow orchestration and all, and they were encouraged, okay, this is the right way to do it actually, because they were able to directly develop workflows, agents on the data where it already lives, right? And that was very important because the data is already insecure. All the security principles are already applied to the data, and MarkLogic fundamental philosophy is, okay, that data security is applied at the place where the data is stored, that is in the database itself, right? So, and those security principles started naturally flowing to the agentic workflow. So if the workflow is a little, if the agent is a little over permissive also, if the ID that is being used to interact with MarkLogic, if that prevents the access to the data, okay, that is the data security is still there, right? So that was that was like a easy way. It took only a couple of days to start it off actually, and after that it was all about okay, making it an enterprise grade application and an agentic workflow. So next slide, Irfan. Okay, so basically what they could achieve is they were able to build the servers fast. It seamlessly integrated with their own to existing data workflows, because for completing a use case story, they had to move out to take a third-party data as well, and that could also integrate with the agentic workflow. So most of the data is in MarkLogic, but a small data enrichment needs to be done by calling a third-party service. So that could be integrated easily. And that proved that it is very, very flexible, and it can support multiple data types, and they enabled into enterprise-grade application very soon. So next slide, Irfan. Okay, so these are some example screenshots, a couple of slides. Next are some example screenshots where with some mock data only, where a chatbot is invoking different MCP tools automatically. This slide that you are currently on, which essentially shows how natural language style queries are asked against unstructured data, which is this one was in HTML data, but I think it was stored as PDF. It is an HTML content converted into PDF and stored in MarkLogic. And a natural language style question is asked against it, and how it the system started responding. Next slide. Of course, the structured data or tabular data, the same chatbot invokes another tool when the input question involves some kind of aggregation from structured data, like grouping customers based on a value, right? Next. Okay, so MarkLogic is also supports graph data. So if the input query can be answered only by traversing a graph data, because it is a relationship-based data and question, then the appropriate tool for generating the Sparkle was invoked. So basically, a natural language question was converted to Sparkle, and that Sparkle get executed by the tool to answer that particular question. And next. And MCP tool, as Irfan mentioned a couple of times, MCP tools aren't just limited to data retrieval. They can execute task-oriented workflows as well, right? Such as booking an airline ticket, or looking up a stock and see whether it can be really, if the stock is available, things like that, right? So in this particular example, the user is asking the agent to perform a customer risk analysis where all the risk rules and the logic are residing inside MarkLogic. Okay, so, and you can also see at the bottom of that screenshot a chaining of the tools actually. So it is calling a chain of tools to complete that particular task, like info search, and then perform the customer risk analysis. And the question itself is, okay, what is the current score, and what is the perform a new risk assessment, right? So it is doing that. It is understanding that question, and the protocol essentially realizes that actually multiple tools needs to be called in a sequence to complete that particular task. So so in this particular situation, beyond enabling rapid development of tool-based agent workflows, the customer also gained an additional advantage. That is, they already had a search application on top of MarkLogic. What they could easily do is, okay, they added a chatbot interface on top of their existing search application. So so the users need not be like retrained on a new application or separate tools. So that streamlined the user experience, and they're also reporting that actually they're significantly reducing the training cost and the operational cost by doing everything in continuing to do everything in MarkLogic. Okay, so what are the steps involved in building an MCP? So these are the high-level steps actually. So some of the things that Irfan mentioned is what is essentially happening here. So of course it is I implemented it using Spring AI. So I have to add all the Spring dependencies. So the MarkLogic also supports Spring applications. So MarkLogic Client API and the Spring AI MCP server dependency needs to be added, and then configure the MCP server for using the properties file for all the kind of injections and bean injections and auto wiring and stuff like that. The important part is the step 3, expose the capabilities of MCP server with tool annotation, right? So Irfan covered this actually. I will just briefly explain the bottom part of the right side of the slide, where there is a at the rate tool annotation, and the description is very important actually, because and the name also, because the name and description is what the protocol and AI model uses to determine and recommend the right tool to use. Okay, so the tool selection cannot be done by the end user. So definitely you would have seen like some publicly available chatbots will have a small drop down at the bottom saying that actually, okay, select the tool, right? But if the user very well knows that actually, okay, my job or my intention is to generate an image, okay, they can select a tool to create an image. But sometimes the user will not be knowing, right, which tools needs to be executed. So the end user might not be like informed well to make the right choice of the tool. So based on the task determined from the user query, the model and the MCP client, that protocol together is what chooses the tool or the tools that should work together to complete the task. So the description of that tool is very, very important. And because internally, that's what gets converted to some kind of exchanges between the client and the LLMs. And the step 4 is implement those capabilities, and which is completely a MarkLogic implementation. Actually, the way that you implement a business logic in MarkLogic, you implement that in the code, and then make the capabilities discoverable using a Spring AI's native thing called a tool callback provider. But connecting that to what Irfan was saying is essentially that what it essentially provides is the client is able to discover the capabilities that are provided by the server, or that capability exchange concept that Irfan was mentioning. So in these 5 steps is what essentially needed to build a MCP server. Means that actually what you all need is Java knowledge and a MarkLogic, and data in MarkLogic is the bare minimum things to build an MCP server, a reliable MCP server in MarkLogic. Next slide. Okay, so best practices, right? So as now everybody knows that actually, okay, this became popular. MCP as a protocol became popular only in November 2024 timeframe. So nobody can claim that actually like I have 5 years or 10 years experience with MCP servers, right? It is impossible. It doesn't exist now. So these best practices, development best practices and management best practices that are still being evolved. Okay. So based on what we generally see, some of the best practices are listed here. I'm not going to go through all of them actually, but again, the most important point is to ensure that each MCP server is considered in a bounded context, focusing on a single domain, and expose the capabilities belonging to that domain only. Okay, so customer domain, and expose the capabilities only for customer through that MCP server. And so that makes it much manageable when it comes to a multi-domain scenarios. And there are security specifications and standards that are published. In my best of my knowledge, it is June 2025 is where the latest updates to the standards were done actually. What it essentially at the top, at the high level, the security principle is security first approach. So you build the MCP servers with security in place, and building on top of MarkLogic gives an additional advantage that if the MarkLogic data security is properly done, then it becomes much easier that MCP servers can be trusted more, that actually there is an over permissive situation doesn't happen. Apart from that, actually, the standard best practices around context size management based on the LLMs that are being interacted with, then appropriately tagging the servers, proper resource management so that it can be discovered easily, and unambiguous determination of the tool, which tool to invoke can be done by the protocol or the tool recommendation. So those are kind of the best practices around developing it. Next slide, Irfan. About the management of MCP servers. So one important question that generally comes is, okay, does MCP increases the security issues around AI? right? So the answer is yes and no. If you do not properly do it, there is a possibility the security, the threat vector or the security premises are changing because of MCP servers. So from a management of MCP servers perspective, a new risk that is generally being heard around is the term that is generally used is called the shadow MCP servers, and people who are familiar with shadow IT might be able to connect it easily. What it means is basically building MCP servers is not that difficult and it is not that complex, especially using libraries like Spring AI or LangChain also has very good libraries around it. So what it happens is, what it also means is that actually there could be untracked, unmonitored MCP servers without a centralized oversight lying out in the network, right? So an over permissive MCP server might be catastrophic, as you can imagine, right? So because MCP servers provide access to your enterprise data, right? So it has to be very carefully understood that actually, and there should be enough security protocols in place at an enterprise level to ensure that unmanaged MCP servers do not lie around. Another important aspect is, again, I'm not going to going through all of them, but one of the important aspect is about the prompt design. So it is very important because it can significantly influence the reasoning and inferencing capabilities, okay, including the tool selection. So consider that description that I mentioned in the tool annotation is a prompt in itself, actually, right? Although that is not called as prompt. From an LLM's interaction perspective, that becomes a prompt also, right? So those descriptions and those they significantly influence the capabilities of the LLM. So make reusable prompts, ensure that the description of tools are very clear for the LLMs, not to make wrong recommendation for the tool selection, because if it makes wrong recommendations, sometimes based on, again, other parts of the prompt, actually there could be there might be like retries and all, actually, but that delays the overall task completion. Okay, next slide. Okay, so fundamentally or the bottom line is good prompts guide complex workflows, right? So design focused secure MCP servers with smart prompts that guide users and clients, that optimize the tool usage within the context limit, right? So that is what is essentially needed. So I will conclude now this section by stating that for a complex workflow to work correctly, good structured prompts with clear and unambiguous instructions are important. Okay, good structured prompts, reusable prompts with clear and unambiguous instructions. That is very important, right? So, and the method with the Spring AI the Spring AI based MCP server that I developed, again, that is and Irfan also mentioned in the beginning, right? The whole ecosystem today is a little bit of developer first approach, actually. So you need to understand code level, API level knowledge, but Progress is in the in works to make it more developer friendly and more closer to the business. So the next part of the session, we are talking about what Progress has to offer, a more flexible and faster way of developing AI agents. So over to Imran to talk about that. Thank you.
Thank you so much, Biju. I think it's really exciting what you did in the MarkLogic space, and how you are trying to solve a problem in the product space by exposing MarkLogic data as MCP servers. So one question that's really I wanted to ask, and you tried to mention that, is that how long did it take for you to build this? How long did it take for you to build this entire system, and also how scalable, how secure it is, that the system that you built?
Yeah. So the initial, I would say, a prototype for an MCP server, thanks to Spring AI documentation, actually, and an example, it took only a couple of days. And my familiarity with MarkLogic was already there, right? So, and I'm a Java person also. So together, it took only 2 days to build it, actually. But definitely, it was not that a simple way to make it enterprise grade, and make sure that actually to make, especially on the prompt side, actually where the issues were, because we have to try different prompts to ensure that the behavior and test for different behaviors, right? So building a a less secure or that kind of a MCP server is not that difficult actually, but making it enterprise grade, I wouldn't say difficult, but at the same time, it is a more a developer job. It's a developer heavy job actually, I would say.
I understand. So basically, you're saying that building a POC is very easy with MCP, but once
Yeah.
you that the enterprise, it needs a lot of effort, a lot of time, and then you have to do a lot of maintenance on top of it.
Yes.
I think this is a good segue. I think this is a good point where we talk about our new product, right? So, but before we even talk about a new product, let's try to figure out how is MCP powerful and where does it lack, you know? So if you think about it, MCP is very powerful, but user queries demand more. If you think about real-time solutions, our data lives in multiple formats. It doesn't just live in one kind of a structure of data that could be accessible using just MCP server if you have to expose it. You might be getting a question from a customer where he wants to get data from multiple third-party data sources like Salesforce, Zendesk, Workday, and then you might also want to get data that is structured, unstructured, where the unstructured data might be living some other place in some other way or form. And at some point of time, you might also want to go to an outside world like internet and then try to extract this kind of data. So when you think about all these different kind of aspects, MCP does solve the right purpose at the right time by retrieving the data at different data sources, but it's not in our control how applications of customers live in. Their applications would be living at different places where they demand the data to be extracted by various protocols and various transports. Sometimes you ask a question, and that one single question might need to get the data touching across various data sources. So how do we solve this problem? We do not, we are talking about only MCP at this point of time, but how do we solve this problem? That is where we are introducing Retrieval Agents Orchestrator. Retrieval Agents Orchestrator is going to be a new product that will be powered with the backup of MarkLogic. What it is going to do is that it's going to solve the problems that we have been talking so far with MCP and go into the space of how we can build agentic solutions that can go and talk across multiple data sources. So Retrieval Agents Orchestrator, in short, RAU, it basically has 4 or 5 different steps. That's it. The first step is reasoning. You ask a question. Based on the question that you asked, it takes the context of your question and then it figures out that you asked a question based on a specific context. So I'm going to rephrase the question for you. So it keeps the context in mind and rephrases the question for you. And then it takes the question and splits that question into subqueries because your question might involve getting data from various data sources. So it's going to split that question into multiple subqueries. And later on, it will choose the right source per the subquery and execute that subtask. In this example here, we have knowledge box, which is your vector data store, could be MarkLogic. And then you want to get data from MCP. You have MCP connector over there. And then you would like to get data from internet for a given subquery. And then it'll go and execute data from internet. And then we can add many other data sources. The idea here that we are going to put is that in an agentic workflow, the data is not just one source, but multi-source. So when you have multi-source data, we are providing you ability where you can we will be creating different connectors or drivers that will help you to fetch the data from various different data sources. And once this retrieval is done from various different data sources, we will merge the answer into one unified answer and present it to the user. Imagine this where you asked a question and that question has to go across 4 or 5 different data sources and give you a summarized answer that has information from an MCP server, from MarkLogic, from internet. as one single answer. That is an amazing response that one would like to see for a given question. And that is what we are trying to build using Retrieval Agents Orchestrator. In addition to that, it also has short-term memory and a long-term memory. It provides short-term memory by tracking ongoing requests and keeps agents from losing context. In addition to that, it has a long-term memory where once the requests are being answered, it stores the queries, retrieves context, and answers. So this way, when you try to perform or build a chat-based application or any kind of AI solutions, that will make sure that it is keeping the context ready available for you for the next questions that keeps on coming to the AI agent solution here. Overall, from the entire presentation and introducing agentic solution here using Rahu, what we're trying to say is that unified intelligence across all data sources is possible with number one, take MCP as your foundation. If you want to build your solutions on top of MCP, it provides you flexible, powerful interface for any data source. It can help you run real world queries, span beyond data. If that's what your use case is, then go for like Rahu, which is retrieval agent orchestration, and it performs smart multi-source retrieval. And it's very, very beneficial for applications to reduce complexity and get unified answers. At the end, I would say MCP plus retrieval agents orchestrator is a centralized, intelligent, and extensible solution that we are powering from MarkLogic, and it would really help you to build solutions which are enterprise grade level. Thank you so much. I think this was a great opportunity for us to talk about what MCP is, how MCP has been implemented, or we are trying to implement in MarkLogic, and then introducing to our new product. Thank you so much. And Sophia, all yours.
Thank you, guys. Thank you so much for this insightful discussion. I hope it was insightful for our audience as well. I'm afraid we're running out of time, but we'll make sure we answer your questions after this session. And just keep an eye out for our agentic retriever and its launch in 2026. Thank you so much.